Students, so today we are going to discuss next part of our first chapter. The topic is, can matter change its state? Okay, we are going to study solid, liquid and gas in this chapter. So can matter change its state from solid to liquid or liquid to gas or gas to solid? Is it possible? And if it is possible, then what are the different factors which are involved? Okay, now see, you all know that water, which is the most common substance that exists as solid, when we take ice, exists as liquid, when we take it as water, exists as gas, when we talk about steam or vapors. Okay, now whenever a substance changes its state, then what happens? This is to be done in this topic. Now, what happens to the particles of matter when this change occurs? Whenever this change occurs, what happens to the particles of matter? Okay, how does this change of state take place? How this change occurs? This is to be studied. Now, two main things which we are going to study here are effect of change of temperature and effect of change of pressure. These two factors are the main factors which are involved for change of state. Okay, now when we will study effect of change of temperature, then three things will come. One is melting point, then latent heat of fusion, then latent heat of vaporization. So these three things are to be discussed in under this heading, change of temperature. So let us start first with an activity. Okay, now you can see this diagram A. This is for this, means conversion of ice to water, and this diagram is for this one, conversion of water to water vapors. Okay, now what we do, we take about 150 gram of ice in a beaker. Okay, this is the beaker. In this we have taken ice first. Then what we will do, we will suspend a thermometer. Its bulb will touch, bulb means the lowest portion of the thermometer, that will touch the ice. Now one glass stirrer is required for shaking purpose. It keeps on moving the contents of beaker. Okay, so what we are going to do is, we will start heating it. This is called Bunsen's burner or burner. Okay, it is connected with gas line. Now what is to be checked? We have to check the temperature when ice starts melting. When we are heating it, then after some time ice will start melting. Now we will keep noting the temperature when this ice keeps on melting. One thing we will notice, that till the whole of ice melts, temperature remains constant and still we are heating from the bottom. हम क्या कर रहे हैं, हम नीचे से इसको हीट कर रहे हैं. एक बार ये थोड़ा सा आइस पानी में कन्वर्ट होगी, लेकिन उसके बाद भी हमने हीट कंटिन्यू रखा और फिर भी वहाँ पर टेम्परेचर इंक्रीज़ नहीं होता है. ठीक है, तो ये कंसेप्ट अभी आगे आएगा, इसे बोलते हैं लेटेंट हीट. तो ऐसा क्यों होता है और वो एनर्जी कहाँ जाती है, वो हम आगे पढ़ेंगे. तो अभी हमने क्या यहाँ पे चेक करना है, we have to note the temperature when all the ice has converted into water. Okay, now once it has changed into water, now this is water. Now again we will continue heating. Now what will happen, now again its temperature will start increasing and then it will change into gaseous state. Now when it changes in gaseous state, then what is the temperature, that is to be noted. So these two things we have to note. Now what happened, on increasing the temperature of solid. See, we have taken ice. Now what we did, we heated it. Now we are heating means we are increasing the temperature. Now what happened after increasing the temperature? Kinetic energy of the particles increases. Kinetic energy we have studied earlier. What is it? It is energy possessed by a substance due to its motion. So kinetic energy of the particles increases. Now due to increase in kinetic energy, what happens? Particles start vibrating with great speed. So in solids, what we studied earlier, that their particles cannot move but they can vibrate. Okay, so their particles will start vibrating. Now when we are continuously heating it, then supplied heat will overcome the force of attraction between the particles. We have studied that there is attractive force between the particles of matter. So whatever energy we are supplying in the form of heat, that energy will become more than the attractive force. Okay, and then those particles will leave each other. They will not hold each other. They will move away from each other. Okay, so what will happen? Particles will start moving freely. They will start moving more freely. Okay, and a stage will come when solid will melt and it will change into liquid. Okay, now that temperature is called melting point. So what is the definition of melting point? The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. Now see, one term has come, atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure is the pressure exerted by the atmosphere at the surface of earth. That is called atmospheric pressure. Okay. Now when we have done this all thing, then that temperature where when ice melts, that point will be equal to 273.15 Kelvin. If in Celsius scale we will see, then it will be 0 degrees Celsius. Okay, so Kelvin scale and Celsius scale, these two scales are related with each other. What is the relation? T is equal to small t plus 273.15. Now see, this is the relation which is to be remembered properly. Here capital T is temperature in Kelvin scale and small t is temperature in Celsius scale. So if question is asked that convert 10 degrees Celsius into Kelvin, so what we are going to do? We will put just the numerical value of degree Celsius here. Then we will add this much, whatever comes with that we will write capital K. So that will be the temperature in Kelvin scale. Okay. Now in case we have to change Kelvin into degree Celsius, then what we will do? Then we will put temperature value here. Okay, then we will bring this term the other side and then we will get the degree Celsius temperature value. Okay, so this is how we calculate or we interchange Celsius and Kelvin scales of temperature. Okay, now this process of melting means changing the solid into liquid is also known as fusion. Okay, now let us study something else. When a solid melts, okay, now here this important concept will come, latent heat. When a solid melts, its temperature remains the same. So where does the heat energy go? Just like I said earlier, that if boiling point of a liquid has come, then we will continue heating it, but what is going to happen? Its temperature will not change, although we will be increasing the heat or we will be supplying the heat, but its temperature will not change. So where this heat which we are supplying will go? This heat will be stored inside it, inside the substance. Means when we are talking about water and we are heating at the boiling point at 100 degrees Celsius, then what is going to happen? The vapors, those vapors will have that extra energy which is being supplied continuously. So temperature of vapors will be 100 degrees Celsius, temperature of liquid will also be 100 degrees Celsius, but that vapors, they will have higher energy, and that energy will be higher by a particular amount. That amount is called latent heat of vaporization. Okay, so why do we use the word latent? Latent means hidden. Latent means hidden. So there are two changes. One change is when solid changes to liquid. So when solid changes to liquid, that time liquid has more energy than solid state, though they are having the same temperature. Let us take the example of water. If we are heating ice and it melts into liquid, then liquid and ice both has 0 degrees Celsius temperature in the beginning till whole of the ice melts. Now what is the difference in energies of ice and water? If both are having 0 degrees Celsius temperature, the energy of water will be more and energy of ice will be less, although they are having same temperature. So what amount of energy is more in water? That energy which is more, that is equal to latent heat of fusion. So these two things we have to remember. Now let us revise this latent heat of fusion. How can we define it? The amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure is called latent heat of fusion. Okay, so particles in water at 0 degrees Celsius have more energy as compared to particles of ice at the same temperature. Okay, now one more term comes here, boiling point. Now what does boiling point mean? When we supply heat energy to water, particles start moving faster, their kinetic energy increases, so they start moving faster. Now at a certain temperature, a point is reached when particles have enough energy to move away and to overcome the force of attraction between the particles. Okay, just like I said that this energy which we are supplying, that energy will have that much value which is more than the attractive forces of particles. So at that particular stage, the liquid will change into gas. Now this temperature when this liquid starts boiling at atmospheric pressure, that temperature is called boiling point. Okay, so two more definitions we have to do, boiling point and melting point. Now let us revise latent heat of vaporization. Amount of heat energy that is required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is known as latent heat of vaporization. Okay, so at boiling point we will be talking about latent heat of vaporization, and at melting point we will be talking about latent heat of fusion. Okay, now similarly particles in steam, that is water vapors, their temperature is 100 degrees Celsius, and boiling water is also having temperature 100 degrees Celsius. So which will have more energy? These vapors will have more energy than water. Okay, why? Because they are having extra energy. How much energy they are having extra? These vapors, they will be having energy equal to latent heat of vaporization. This much energy will be more. Okay, so from this discussion we can say that state of matter can be changed into another state by changing the temperature. If we change the temperature, then we can change the state of substance. Okay, now let us talk about these three states: solid state, liquid state and gaseous state. Okay, how can we convert them? If we heat a solid, then it changes to liquid state. If we heat a liquid, then it changes to gaseous state. Similarly, if we do the reverse, if we cool the gaseous state, it will change to liquid state. If we cool the liquid state, it will change to solid state. Okay. Now, what is the effect of change of pressure? Okay, now we are talking about pressure. Is there any effect of pressure or no? This is to be discussed. Now, difference in various states of matter is due to the difference in the distances between the constituent particles. This we are going to see in the next diagram, which will come after this. So, what we are saying, that various states of matter, how they differ from each other, the particles are having different distance. If the distance is very much, then we will say it is gaseous state. If distance is the minimum, then we will say it is solid state. Okay. Now, when we put pressure, then what happens? Okay, whether the particles come closer or no. And if they are coming closer, then can a gas be liquefied or no? This is to be checked under this. Okay. Now, let us discuss one more thing. There is a substance called solid carbon dioxide. Okay, this is also known as dry ice. Now, how can we get solid carbon dioxide? Carbon dioxide is a gas. What we will do? We will cool it and then we will apply high pressure. When we do this, then it changes to solid state. Okay, and then it looks like ice, just like ice is white. So it looks like ice, but ice has the property that wherever we will place, it will wet the surface. But where we will place solid carbon dioxide, it will not wet the surface, but it will look like ice. So we say it is dry ice. So solid carbon dioxide is known as dry ice. Now look at this diagram. Here we have taken gaseous state, this is liquid state and this is solid state. So what we did? In case of gas, particles are at large distance. In case of liquid, they are at less distance. In case of solid, they are at minimum distance. So when we are applying pressure, then we can change the positions of these particles. If these particles come very near to each other, then it may be solid state or it may be liquid state. So it depends on the pressure which we are applying. Now one more diagram you have to remember. Once this question came for 3 marks, so you have to learn this very properly. See, in this diagram we have shown the interconversion of solid, liquid and gas. See, we can convert solid to liquid and that process is called fusion. Similarly, liquid to gas, and that process is called vaporization. Gas to solid or solid to gas, this is to be remembered this way: solid to gas or gas to solid, this is called sublimation. Okay. Now if we say liquid to solid, then it is called solidification. If we say gas to liquid, then it is called condensation. So you may be asked 1 mark question, what is fusion? So what you will say? You will say process of conversion of solid into liquid is called fusion. What is vaporization? Process of conversion of liquid into gas is called vaporization. What is sublimation? Process of conversion of gas into solid or solid into gas is called sublimation. So this way you have to explain. Now we have discussed so much, so on the basis of this you have to solve these assignments. In case of any doubt you can ask. Thank you.